Toyota is known for its top-tier cars, but now it's making a name for itself in basketball. No, I'm not talking about a Japanese Steph Curry, but rather Q, a humanoid robot basketball player that broke the world record for the longest ever basketball shot.
This is the world's longest basketball shot.
In 2022, Joshua Walker from the USA set a new world record for the longest basketball shot.
Sorry, kid, not anymore. Q is a basketball sensation that uses vision, motion planning, and control technologies to detect targets, estimate distance, and execute precise shots. The robot doesn't mimic human shooting motion, but rather adapts to its shooting style all on its own. Not only is Q a three-point whiz, it also set a Guinness Book record by making more than 2,000 consecutive free throws before being told by its team to take a rest. But what is the developer's real ambition with Q?
マイケル・ジョーダンのダンクのような
To be like Mike, of course. And for engineers ambitious with their designs, they need reliable parts. And there's no better place to source them than Mouser Electronics. ABB CE4 emergency stop buttons are compact, durable safety devices designed for reliable machine shutdown. They feature a 40mm mushroom actuator with red or black options, available illuminated or non-illuminated. Multiple release mechanisms including twist, pull, and key code 455 provide flexibility. Built with dustproof and waterproof protection up to IP69K, they excel at harsh environments. Self-cleaning contacts enhance long-term reliability, while various contact configurations support different control needs. Compliant with major safety standards, these ready-to-install e-stops are ideal for automation, industrial, machinery, and automotive applications. Check out the ABB CE4 emergency stop buttons today by visiting Mouser.com or by clicking the link below. What are some screw and screwless terminal types important to engineers? To demonstrate, we present David's Corner.
Thanks, Andy. In the past, we've talked about different types of terminal blocks, but there's a few different ways that the wires can actually be connected into the terminal blocks, regardless of which type you're using. So we're gonna look at three of the most common. The first one and most traditional is the screw down type of terminal block, where we insert the screwdriver and we can loosen and tighten, inserting the wire from the side or from the top. And we can tighten down the wire, usually with a torque screwdriver, to be sure that we have a secure connection. And then we can remove the wire. Pretty straightforward. Somewhat more recently is a spring type of terminal. They call this a screwless terminal, but there's a few variations of screwless. In this case, we can plug in the screwdriver and use it to open a panel on the side. And we can plug in the wire. And when we release the screw, the wire can come back out. The final type, which is one of the newest types that we're seeing emerging in panels, are not only screwless, but you don't even require a tool to connect it in the first place. We simply plug in the wire and we hear a click and we have a secured connection. It does require a tool though to remove the wire. This is a really interesting and innovative kind of connector that are called snap connectors. And a few companies are using this type of variation to make it much easier for automation systems like robots to simply be able to pick up wires and connect a panel and wire the panel in an automated fashion. So there's lots of different types of terminal blocks out there with lots of really cool wiring styles that you may run across in your adventures. Andy, back to you.
Thank you, David. All right, it's time to adjust your knowledge gains in our Smart Bit quiz with our 4 control automation questions. The questions are scored using actuator output percentage, and today we're going to help that nice fellow at Toyota achieve his dream of creating a Michael Jordan-like robot basketball player. We'll call him Jordy. Let's begin with our first question about Jordy for 25%. During a fast break, how should Jordy optimize speed while maintaining stability? Is it A, adaptive gate control with real-time feedback, or B, fixed high-speed gate pattern? And the answer is A, adaptive gate control with real-time feedback. Adaptive gate control continuously adjusts stride length, timing, and balance based on sensor feedback, enabling high speed without sacrificing stability. Okay, let's move on to our next question worth 25%. For Jordy to achieve maximum vertical leap for a slam dunk, which control strategy is most effective? Is it A, open loop torque burst, or B, optimal control with trajectory planning? And the answer is B, optimal control with trajectory planning. Optimal control plans joint torques and timing to maximize jump height while maintaining balance and respecting actuator limits. Okay, let's move on to our next question worth 25%. During mid-air motion like a dunk, how does Jordy control its body orientation? Is it A, conservation of angular momentum through joint motion, or B, reaction forces from the ground? And the answer is A, conservation of angular momentum through joint motion. Once airborne, the robot cannot rely on ground forces, so it adjusts limb positions to control orientation using angular momentum. Okay, let's move on to our final question worth 25%. For a controlled and safe landing after a dunk, which approach is best? Is it A, passive joint damping only, or B, active compliance with force feedback? And the answer is B, active compliance with force feedback. Active compliance uses sensor feedback to absorb impact forces and maintain stability, reducing damage and preventing falls. Want to try again? Just click the link on your screen and be sure to check out our other Automator's Edge videos for the latest in control automation.